Right, my dear children? So we have discussed about all the theoretical parts related to the magnets lesson. Now we are going to discuss about some questions related to these magnets. So first of all, we'll be heading to questions which are given in your textbook. So the first question which is given in the textbook is, select the appropriate words from the brackets and fill in the blanks of the paragraph given below. So we need to fill the blanks by using the correct words on the brackets. So materials that show magnetic properties are called. So on the first part of our lesson we discussed the materials which shows magnetic properties are called as magnetic materials. So we'll find out the answer, magnetic materials, from this thing. Yes, you can identify magnetic materials at the second. So we'll include magnetic materials. Magnetic materials. Magnetic materials. The best material to make permanent magnet is, to make permanent magnets we use steel and ferrite. Those are the ones which used to make permanent magnets. So we'll find out whether those two answers are given in this bracket or not. So we'll find out. So here it's given with soft iron. So I told you that soft iron is not being used to create a permanent magnet. We use soft iron to make simple. We use soft iron to make temporary magnets. So soft iron is being used to make temporary magnets. So we need to find out. Remember, we need to find out steel or ferrite. So here you can find the ferrite. So ferrite is the answer. Ferrite. Right. To make temporary magnets, so once again, to make temporary magnets, then we use the soft iron. Soft iron. So to make temporary magnets, soft iron is commonly used. The area in which magnetic force exists is called, the area which the magnetic force is going to exist, or the magnetic power is going to exist, is called as the magnetic field. So here you can observe the magnetic field is given here, magnetic field. Magnetic, not the magnetic field lines, but the magnetic field. Magnetic field. Magnetic field. Magnetic field. Influence of a magnetic field can be observed using, so influence of the magnetic field, we observe that thing by using the magnetic field lines. So magnetic field lines is the one which we can use to observe the effect or the influence of a magnetic field. So magnetic field lines. Magnetic field lines. Influence of a magnetic field can be observed using magnetic field lines. Then the next one, the area on a magnet where the magnetic forces are concentrated is known as, so when we take a magnet, the area which the magnetism is going to concentrate is referred as a magnetic pole. So there are two poles in a permanent magnet, so in any kind of a magnet, we can observe two poles. Those two poles are the north pole and the south pole. So my dear children, the area on a magnet where the magnetic forces are concentrated is known as the magnetic poles. Inside the magnetic poles, we can observe, or on the magnetic poles, we can observe the greatest magnetic power or the greatest magnetism. So highest amount of magnetism, the magnetic power could be observed in magnetic poles. So these are the answers for the first question given in your textbook, right? So we'll move on to the next question then. So in the next question, you are given with a figure. In this figure, you can observe a pencil box. This is a pencil box. So given below is a rough sketch of a pencil box that closes with the help of a magnet. By using a magnet, we can close the lid of it. Suggest a method to test whether the magnet is fixed on the box or on the lid. We need to suggest a method. We need to suggest a method to find the magnet, whether it is being fixed on the box or whether it is being fixed on the lid. So you have to suggest a method. Okay, we can find whether the magnet is fixed onto the box or to the lid by using two ways. You can use two different ways. Okay, right. First of all, you can take a magnetic material like an iron nail or else a needle, a blade, a hacksaw blade, whatever. You need to find out a magnetic material. Then take that magnet, we'll imagine that this is my magnetic material now. So you take that magnetic material near the lid first. Take the magnetic material near the lid first and see whether the material is getting attracted to the lid or not. See whether the material is getting attracted to the lid or not, right? So if it is getting attracted towards the lid, you take the magnetic material and you place it here. Then if the lid is attracting towards the magnetic material, right? If the lid is getting attracted towards the magnetic material, then we can conclude that the magnet is on the lid. It's because that magnetic materials are attracted only towards a magnet. Like if you take an iron nail, if you bring near that iron nail to a magnet, then it will attract. So by using that thing, you take an iron nail towards this lid. So if the lid is getting attracted, then definitely the lid has the magnet. Then separately take, after doing that experiment, if it is positive, then we don't need to conduct the experiment for the box part, right? If the observation is negative, means that if the lid is not getting attracted, then we can take the iron nail, then we can take it near the box and to see whether the iron nail is attracting or not. Okay, so at one of these instances, the magnetic material should attract towards the metal, towards this piece, to this piece or to this piece, whatever, right? During only one instance only, the material is getting attracted to the lid or to the box, right? So therefore, by the attraction of that, we can say that the material or the magnet is being included in that sort of part. So here You can write down the method like this. First get an iron nail and bring it closer to the lid part. Observe whether the nail so first get an iron nail and bring it closer to the lid part. Observe whether the nail is attracted. So if it is attracted, then lid part contains the magnet. If it is attracted, then lid part contains magnet. Right? Lid part contains magnet. Then we can write, if not, then the box part contains the magnet. If not, box contain right. If not, box part contains the magnet. So this is the first method. So I'll mention method 1 at the top. So this is the first method that we can use to observe. This is the first method which we can use to observe, which we can use to find out whether the magnet is being fixed on the lid or on the box. The first method, right? There's a second method of doing this thing. How come? You can use a simple magnet, a smaller bar magnet. You can use a smaller bar magnet or any type of a magnet. And you can bring that magnet near this lid part. So definitely that will attract in the first instance. Now you need to interchange the two terminals. And bring it near the lid. If the magnet is contained in the lid, at the first instance, if the magnet is attracted towards the second magnet, then when you are going to interchange the two terminals, at that instance, the lid should be repelled with the magnet. It's because that when terminals are interchanged, we are bringing like poles together. So like poles should definitely repel each other, right? So if it is not repelling, if it is once again attracting, now in that situation we can say this is the metallic part or the magnetic material part. right? At the both instances, if this lid part is getting attracted towards the magnet, then it contains only a metallic part, means a magnetic material. Then definitely this part contains the magnet. It's really simple. We'll imagine that this is my north pole, this is my south pole of the magnet. Or else you can use an unknown magnet as well. A magnet which you can find in your motor, a small bit of a motor, or else in a speaker. That thing can be taken, right? So let's imagine that I have a marked bar magnet like this. This is my north pole, and this is my south pole. Now I'm going to bring this north pole near the lid and see whether it is getting attracted. So if it is getting attracted, I'm going to interchange my terminals, and now I'm going to bring it in here to see whether it is getting attracted or not. If it is getting attracted at the same in the second time also, then definitely this is just a magnetic material like a metal piece of metal. If it is getting repelled, then we can say that this is a magnet, because in the first instance, unlike poles are getting attracted. When I am going to interchange, like poles are getting contacted, so therefore it will repel, right? So that's the second method. So we'll write the second method also. I'll take the slide somewhat up. Method 2. Take a magnet and bring it near the lid and see whether it is attracted or not. Then change the terminal of the magnet and bring it near the lid again. Bring it near the lid again. See whether the lid is attracted or not. So in the next step you can write, if the lid is attracting in both the occasions, then box part contains the magnet, right? If the lid is attracting only in first or second occasion only, and in the other occasion if it is going to repel, then lid part contains the magnet, right? So if if the lid attracts, if the lid attracts to the magnet in both occasions, in both steps, if the lid attracts to the magnet in both steps, then box part contains the magnet. Box part contains the magnet. Reason for this thing is, we can write, I'll mention that thing within brackets. When interchanging terminals of the magnet, terminals means the poles, terminals of the magnet like poles. Like poles means north or south. Like poles should come in contact and at least in one step there should be repulsion. Right. So this is the way of identifying whether the magnet is being fixed onto the box or to the lid by using the second method. Here we can use a simple magnet. What you have to do, you have to bring near the magnet to the lid first, and you have to interchange the two terminals and bring near the magnet once again. At least in one occasion or at least in one step, there should be a repulsion, because the like poles are getting contacted each other when you are interchanging the two terminals, right? So when interchanging the terminals of the magnet, like poles should come in contact, and at least in one step there should be repulsion. So at least in one step there should be repulsion, right? So if the repulsion is not occurring, right, if the repulsion is not occurring, then that part do not contain the magnet. If the repulsion is occurring, then that part definitely contains the magnet. So this is the way of identifying the magnet by using the second method, right? So if the lid attracts to the magnet in both steps, then box part contains the magnet. Then in the next step I can write once again. If not, I'll use the same blue color. I'll use the same blue color one. If not, I'll use the blue color one. So in the next step, if not, the box part contains the magnet. right? So this is how to identify whether the magnet is being fixed on the box or on the lid. So we can use either of these two methods to identify the place. Okay, so we'll move on with the next slide to observe the next question. A student who checked some magnets in the school laboratory found out that their magnetic force is worn out. Give 3 reasons for that. Now, when you go to your laboratory, you may find different types of magnets. Now, these magnets, we don't know whether these magnets are being placed for a longer time period or not. We don't know for how much of a time period. We don't know how much of a time period are these magnets being placed on that laboratory. So therefore, in order to check the magnetic effect or the magnetic field, we need to bring those magnets and check whether they have a magnetic field by putting some pins and iron nails. You can check out the magnetic field. So some students have conducted an experiment to identify the magnetic field, and they could observe that in some magnets the magnetic field was worn out. So give 3 reasons for that. We have to mention 3 reasons for it. So I'll mention all 4 reasons in here, right? We studied 4 reasons. We studied 4 reasons that causes the depletion of magnetic field. So we'll write all of these 4 reasons. So we discussed that after some time, I told you that magnetic field of a permanent magnet is going to deplete in very smaller amount within 1 day. So when the time is going to pass by, that small bit of worn out part is going to be collected together to form a larger value. So when time is going to pass by, magnetic field is going to drop down in a huge amount or in a huge context. So the first thing is aging. So when time is going to pass by, or when a magnet is going to age, in that kind of a scenario, magnetic field is going to be lost. So magnetic field is going to lost due to aging process. So we can write number 1, aging. Aging. Right. Then the next one. Next reason is, if these magnets are being if they have been subjected to several vibrations, I mean, like if they have been dropped down to the floor, or else some student, whether some student or any other person, he has taken these magnets and he has hit on a different material, or in a floor, or in iron, or between 2 magnets together. If that student or if that person has done like that sort of a thing, so in that case a vibration is going to occur. So if a magnet is going to face if a magnet is going to face high amount of vibrations, in that situation also the magnetic power will be lost. So the second factor is vibrations, subject into vibrations. So subject into vibrations. Subject into vibrations. This is the next one, next factor. Then the third factor, we did these experiments earlier. We heated up a magnet and observed whether the magnetic power lost or whether the magnetic power has depleted or not. So our observation was quite easy. we observed that magnetic power has lost when a magnet is being heated. So, the third factor is subjecting to high temperature. Subjecting to high temperature. This is the third one. Then finally, now you know that these magnets are being stored together. So if one magnet is somewhat stronger than the other, then sometimes due to that strong magnetic fields, the magnetic power or the magnetic effect of a magnet may lost. So the fourth and the final factor is subjecting to high or more stronger magnetic fields. So subjecting to strong magnetic field. Subjecting to strong magnetic field. So these are the factors which depletes the magnetism or the magnetic field of a permanent magnet. Right. So we'll move on with the next question then. So here the fourth one, explain scientific reasons for the following. We need to explain the scientific reasons. North pole of a bar magnet hung freely by a thread is directed towards north. You know that when we hang a magnet freely in air, then that magnet would turn to north and south directions of our earth. It's because that we discussed that our earth contains a thing called the geomagnetism. It's a magnetic field that surrounds our earth. It creates due to liquefied metal currents which runs around the core of the earth. So this magnetic field around our earth is the one which is responsible for the turning of the compass or the magnet, right? So in a compass also the same thing is going to happen. We discussed that thing. In a compass we use a simple magnet, right? So these magnets in a compass or any other place, when they are pivoted freely or when they are hung freely, they would rotate and turn to north and south directions due to geomagnetism. So we can write the answer: Earth has a magnetic field Earth has a magnetic field which runs from north to south pole, which runs through north and south directions. So you know that this is called as the geomagnetism. So I'll mention that thing within brackets, geomagnetism. So therefore when a magnet is hung freely, it align or it is directed towards north. Right, so this is the explanation for that question. Earth has a magnetic field which runs through north and south directions. It is called as the geomagnetism. So therefore, when a magnet is hung freely, it is directed towards north and also south. I'll mention and south. North and south. Right? So it is pointing towards north and south. This is our explanation for the answer. Then the next one. A piece of iron is attracted towards a magnet, but a piece of copper is not. A piece of iron is attracted towards a magnet, but when you take a piece of copper, it's not getting attracted. What is the reason? Reason is quite simple, my dear children. It's because that iron is a magnetic material. It shows magnetic properties. So therefore, iron is getting attracted to the magnet. But if you take copper is a non-magnetic material. Even though it is a metal, it doesn't have magnetic properties. So therefore, copper is not getting attracted to the magnet. So we can write iron is a magnetic material. Iron is a magnetic material. Therefore, it is attracted to a magnet. Copper is not a magnetic material. Copper is not a magnetic material. Copper is not a magnetic material. Therefore, copper is not attracted to a magnet. Therefore, copper is not attracted. To a magnet. So this is our explanation for the question. Iron is a magnetic material. Therefore, it is attracted to a magnet. Copper is not a magnetic material. Therefore, copper is not attracted to a magnet. So, iron is a magnetic material, but copper is not. Even though copper is a metal, it is not a magnetic material. This is our answer for the question then. Right. Then the fifth question, children, let's see. An iron rod placed on a table was contacted several times with a bar magnet. Then it was observed that pins and small pieces of wire are attracted to the iron rod. Now here iron rod placed on a table contacted several times with a magnet, a bar magnet. It was observed that the pins and small pieces of wire are attracted to the iron rod. So here now we have discussed how to make a permanent magnet by using two different methods. One method out of that was the contact method. So in contact method, we took a magnetic material like an iron nail, a needle, a hacksaw blade, like that, and we rubbed that material against the magnet. So after rubbing for some time, we could observe that the magnetic material also has some kind of a magnetic field, so that it can attract different magnetic materials. We discussed that activity under the making of, or else under the construction of, a simple permanent magnet. So here also in this question, the person has contacted a bar magnet on an iron rod. So in this situation also the contact method is being used. So therefore here the iron rod is behaving as a permanent magnet. So we'll see. Give reasons for the above incident. What is the reason? Because the iron rod is behaving, or iron rod has become a permanent magnet. Because iron rod has become a permanent magnet. Right here, because iron rod has become a permanent magnet. This is the reason. Second question, what is the term used for the above process? So this process is referred as the contact method of making a permanent magnet. Contact method. Suggest another method to get the same result without using a permanent magnet. So without using a permanent magnet, like a bar magnet over there, we can create a permanent magnet by using the electrical method. Right? So suggest another method to get the same result without using a permanent magnet. So we can use the electrical method. So I'll take the slide somewhat up. Right. So answer is electrical method. So we'll explain how to do the electrical method once again. So in making a permanent magnet by using the electrical method, you will be needing these materials. So materials, copper coil, cardboard sheet, or else just a paper. I'll mention paper, iron nail, then a dry cell. Then what you have to do? I'll draw and show the figure. So first of all, we need to make a tube like this by using the paper. So this is the paper tube. Then we need to insert that iron nail. We need to insert that iron nail. We need to insert that iron nail to the paper tube like this. Okay. Then we need to wrap that coil around the iron nail, around the paper tube like this. We need to wrap the coil around the paper tube like this. Then these terminals are connected to our dry cell. I have used the circuit symbol, but I'll show the dry cell like this, right? Okay. Now we need to pass electricity for some time using the dry cell to the coil. Then after some time you can observe the magnetic effect on the iron nail, right, my dear children? So this is the way of doing the experiment. So we'll write down the steps of doing the experiment then. So we'll write down the method. I'll use a different color. So first of all, you need to make a tube according to the figure and wrap the coil around it. Okay, wrap the coil around it. So we'll write make a tube using the paper, and wrap the coil around it, and wrap the coil around it. Wrap the coil around it. Then in the next step we can write supply current to the two terminals of the coil and make a permanent magnet by using the iron nail. Before that we need to insert the iron nail into the tube. So insert the iron nail, to the tube. Insert the iron, here it is not the iron nail, iron bar. The question is given as iron bar. No. So insert the iron bar, or else insert the iron, insert the piece of iron, or insert the iron to the, I'll use the bar thing, it's good. Insert the iron bar to the, now in the question it is given as an iron bar, no? So I'll erase these two parts at the end to make it into a bar like this. It's given as an iron bar, no? So we'll use the iron bar. Okay, like this. So insert the iron bar to the, paper tube. Insert the iron bar to the paper tube. and supply electricity to the two terminals of the coil. To the terminals of the coil. That's it. So this is the way of creating a permanent magnet by using the electrical method. So when you take out this iron bar, it behaves as a permanent magnet. So let me name the materials in here. So this is the iron bar then. This is the dry cell. Always, my dear children, if you are being asked to draw a figure, then make sure to name the parts in it. Right? Like this, name the parts in it. So this is the way of making a permanent magnet by using the electrical method. Right. So let's move on with the next question then. Right, my dear children, we discussed all the exercises related to the textbook. Now we are moving to the questions, some extra questions to discuss about this magnet lesson. So the first question, we'll see, choose the most accurate answer. So here you need to select the most accurate answer from the given 4 responses. First question, not an example for a magnetic material. Not an example, shouldn't be an example for the magnetic material, right? So the first question, in the first response, you can get the answer, you can find the answer. So copper is the one which doesn't show any magnetic properties. So copper is the one that do not show magnetic properties. All the other materials, they show magnetic properties. Ferrite, even we use ferrite to create permanent magnets. Iron, that is also a magnetic material. Then steel, that is also a magnetic material. All of these materials are getting attracted towards a magnet. So copper is not an example for a magnetic material. Copper is the answer. 2 materials that can be used to make permanent magnets. So the main material we use to make permanent magnet is ferrite. We use ferrite as the main material. Then the second material is steel. We use steel to make permanent magnets. So ferrite and steel are the correct responses. So steel and iron cannot be used to make permanent magnets, because after some time, you know that iron is going to reduce, or iron is going to lose the magnetic power, magnetic effect. So we use steel or else ferrite. So steel is correct, but iron is not. Aluminium and copper, both of these materials do not show any magnetic properties. So aluminium and copper is also incorrect. Then here you can observe the third response, the correct answer, steel and ferrite. We'll move on to the fourth one also. It's given with soft iron. So soft iron is a material which used to create temporary magnets, but not permanent magnets, my dear children. So we are being asked to find out the materials or the things which used to make permanent magnets. So we use ferrite and steel to create permanent magnets. So in the next question, you need to choose the incorrect statement about the compass. The incorrect statement about the compass used to identify directions. So that is correct. That's the most obvious case of a compass. We use a compass to identify the directions. So it is correct. Japanese have invented compass. So that part is incorrect, because Japanese are not the Japanese, but the Chinese people are the ones who found out the compass. So this is the one which is incorrect. So this is incorrect. I have underlined the incorrect part, but we'll see what are the other responses as well. So it contains a free moving magnet. Contains a free moving magnet. So that is also correct. Compass is being created by using a free moving magnet pivoted around a structure. So that free moving magnet eventually turned to north and south directions due to geomagnetism. So this is also correct. There are digital compasses. That is also correct. If you take your smartphone, in a smartphone we can observe there is an application called the compass. So in that application there is a digital structure or this digital interface, right? So there are digital compasses as well. It is correct. So the fourth one, for the fourth question, you are given not a method to identify poles of a magnet which are not marked. Not a method. Not a method. So the first response is given floating on water. Floating on water. So that response is correct, because if you take an unknown magnet and if you are going to release in water by using a structure like a regiform board or else a cardboard, when you keep it on the water basket, then eventually it will turn and eventually turn to north and south directions. It's because of the geomagnetism of our earth. That's how the compasses are also being made. So this response is correct. Floating on water. Then by using a compass, yes, that is also correct. We can bring near the compass needle which directed towards the north. First of all, we need to find out the north and south directions by using the compass needle. So by that way we can identify the north and south poles of the compass needle. Then we need to bring it near this unknown magnet. So by that way, by the attraction, we can find out what are the poles of the unknown magnet. If the north pole of the compass is attracting towards the if the north pole of the compass is attracted towards a terminal of the unmarked magnet, then that pole or that terminal is the south pole of it, because the opposite poles are the ones which is getting attracted, right? So like that way we can find out the poles by in an unknown magnet by using a compass. So it is also correct. Hanging freely in air, that is also correct. The same thing is going to happen like in the first step, in the first response. So in the first response it's given floating on water. So when you hang the magnet, that in that instance also it will rotate and turn or will direct towards the north and south directions. So this is also correct. Then the fourth one should be the incorrect one. We'll see by using iron powder. So that's the incorrect one. By using iron powder we can't find out the poles, right? So that is the incorrect one, by using iron powder. So we'll move on with the next question. Place where permanent magnets are used. Permanent magnets, right? Permanent magnets. Place where permanent magnets are used. So remember the term permanent magnet. In cranes, no, crane is the weightlifter. Crane and weightlifter both are same thing, right? Weightlifter and cranes both has the same mechanism. They use the electromagnet. So when you disconnect the electricity from the magnet, the materials or the stuff or the weights are going to fall down, right? So weightlifters, that is also incorrect. In that instance also we use the electromagnets. In motors, yes, this is the answer. When you take a simple motor, right, in motor we use permanent magnets. Then the fourth one, electric bell, that is also incorrect. So the correct answer is motors. In motors we use permanent magnet. Next one. When north pole of a magnet brought near to a north pole of another magnet, the two magnets will. When north pole of a magnet brought near to a north pole of another magnet, two magnets will. So north pole, north pole. North pole, north pole means those are like poles. So like poles always going to repel each other. Always like poles are repelled, unlike poles are attracted. So they would repel each other. This is the answer, right? They would repel each other. If you bring near north pole to a north pole in two different magnets, then the two magnets will repel each other. So attract each other, it is incorrect. No change, that is also incorrect. It at first attracts and then repels, that is also incorrect. So the correct response is repel each other. Right. You have to choose the most correct answer. Then once again, the seventh question. A and B are two things. A and B are two things. We'll imagine those things are two materials then. When A is brought near to B, let's draw a simple figure then. This is A, this is B, right? When A is brought near to B, so I'll draw two arrows here. A is brought near to B, B attracts to A. I'll use a different color. So it attracts. When poles of A are interchanged, now I am going to interchange this thing. So I'll mark one pole like this in A. Okay. So when poles of A are interchanged and brought near to B, now we are interchanging. We are interchanging the two poles like this. This is that line. Okay, that line should be at the other end then, if I am going to interchange it. Okay, right. And then A. So I am going to bring it near once again. This is B. So you can see that this is the marked one and this is the marked one. So I am bringing that marked one near to B. So in that case it attracts. So when poles of A are interchanged and brought near to B, still B attracts. Still it attracts then. Still it attracts. So in both the occasions, B is going to attract towards A. So we can conclude that. You can remember at the earlier instance where we were in the textbook exercises where we were given with a pencil box to find out the magnet. So in that case, in the second method, we chose a magnet and we brought near a magnet and we concluded that if the magnet is getting attracted, right? If the magnet is getting attracted, both the instances, then it is just a magnetic material, because at least in one step, when you interchange the two terminals, at least in one step, if it is a magnet, at least in one step, the other magnet should repel, because the like poles are getting collected each other, or because the like poles are getting contacted each other when I'm going to interchange the two terminals. But in this case, you can see that in both the cases, this material attracts. So definitely that B material should be a magnetic material like iron, steel, like a needle, like that, right? A definitely that one should be a magnet. Otherwise, it can't attract those magnetic materials. So, A is a magnet and B is a magnetic material. We'll select the answer. A magnet, B magnet. Incorrect. A iron bar, B copper sheet. Incorrect. A magnet, B iron nail. Absolutely, this is our answer. A should be a magnet and B should be a iron nail. That is why if you are going to interchange the two terminals, that is why the iron nail attract towards A. Because iron nail is a magnetic material, it doesn't have any magnetic poles. So therefore, no matter when you are changing the terminals, it always attract towards the magnet. Right. In the fourth one, it is given iron nail and iron bar. Both the materials are just magnetic materials, right? So therefore, we can't observe any attraction in that moment, right? So this is the answer then. Third one is the answer. Figure which shows attraction of iron powder to a magnet. If you take a magnet, when you put iron powder into it, it always attracts. Iron powder always attracts, or iron powder always going to attract for the two terminals or for the poles of a magnet. So if you take a bar magnet, poles or the area which the magnetic power is concentrated can be observed at the two ends of it. So most of the iron powder should be at the two ends, not on the middle, not evenly spread, but most of them should be at the two ends. So select the response which has more iron powder at the two ends. So you can observe this C. C is the one that has that feature. So C is the figure which includes the iron powder on a bar magnet. Right. So instrument that use an electromagnet. Instrument that use an electromagnet. We need to find out, we need to select an instrument which use electromagnet. Dynamo. Dynamo is incorrect. In dynamo, we use a permanent magnet. In dynamo, we use a permanent magnet. So we are being asked to find out where an electromagnet is being used. So in dynamo, we use electromagnet. Next one, motor. In dynamo, we use not an electromagnet. In dynamo, we use a permanent magnet. In dynamo, we use a permanent magnet, but we are being asked to find out an instance where an electromagnet is being used. So we can't take dynamo because in dynamo, we use a permanent magnet. Second one, motor. Motor. Now in a motor, there are some cases which we use permanent magnets, and also you know that in large motors, under that extra knowledge part, we discussed that large motors use electromagnets as well. Here just it is given with motor. So in some motors we use permanent magnets as well as electromagnets. I'll keep the motor answer in this way and we'll move on to the next thing. Next thing is given as the crane. In a crane or else the weight lifters, definitely that one is a electromagnet. Definitely, I mean almost all the cranes, 100% of the cranes are using electromagnets, because when a crane is going to operate, it's going to lift some weight and we need to drop it on a different place. So to drop it, we need to cut the electricity. In that case, the magnetic field also going to be lost. That's how we can unload the weight. If it is a permanent magnet, then we can't unload it. There's no possible way to reduce the magnetic field or to kill or cut the magnetic field. So therefore, in all the cranes, we use electromagnets. So we need to select the most accurate answer, my dear children. The most accurate answer. So there might be some answers that has several correct responses, but the most accurate one means we need to select out the best answer that would match the scenario. So in this case, we have to select cranes but not the motor, because in smaller motors, we use permanent magnets, right? So in this situation, we have to select the most accurate answer, which is the crane. So in speaker also we use the permanent magnets. So this is also incorrect, right? Then the next question, 10th one. Magnetic power depletes in a magnet due to, right? Falling often to the ground. First one is given, falling often to the ground. Second one, subjecting to high temperature. Third one, subjecting to high magnetism. So let me remind all four cases of losing magnetic power. Aging, subjecting to high temperature, subjecting to vibrations, and finally, the given thing in here, subjected to high magnetism. So my dear children, in this case, all of the responses are correct. So the correct one is all of above, right? This apparatus is used to. Now here you can see an apparatus. You can observe, like here, a paper or else a cardboard. I'll write it as a paper or else it is a cardboard. And here you can observe, this one. Here you can observe the rod which is inserted to this. This is the iron rod. The iron rod which is inserted to the plastic tube or the cardboard tube or the paper tube. You can use any material here actually. It shouldn't be a metal, that's the case, right? It can be a paper, a plastic rod, right? Now when we are doing the activity at the lab, this activity, we did this thing at the lab. I think you could remember it. In that case, we used a PVC pipe, right, as the insulated area. So here you can use anything, but it should be an insulator. Insulator means a material that do not conduct electricity. An insulator. So here you can see the insulator, and there is the iron rod. You can see the iron rod, and electricity is supplied to the iron rod from the coil which is wrapped on the insulated area. So this is an example where we use to prepare, or where we use this is an instance where we use electromagnets. So this is a simple activity where we produced an electromagnet, right? So let's see what are the answers and what is the question given here. This apparatus is used to, number one, make a permanent magnet using electrical method. Make a permanent magnet by using the electrical method. Second one, make a permanent magnet using contact method, making electromagnet, making a simple compass. So this answer is really obvious to us. Here, electricity is being supplied through an insulated tube to the iron rod. Then after that, you can observe some file clips are getting attracted to that rod. Means that this rod has become a permanent magnet. So here we have used electrical method because we have supplied electricity, no? So we supplied electricity to create a magnet. So this is a permanent magnet because after disconnecting the electricity, the magnetism remains or retains in the iron rod. So here we have made a permanent magnet by using the electrical method. Next question then. Things which are not attracted to a magnet. Things which are not attracted to a magnet. So these answers are also obvious. You know that there are some materials which are magnetic materials. The materials which are getting attracted to a magnet. And there are non-magnetic materials as well. Materials which do not attract to a magnet. So here they are asking about things which are not attracted to a magnet, means non-magnetic materials. So select the two non-magnetic materials. Number 1 is given copper and regiform. Yes, that's our answer because you know that already. Copper is a non-magnetic metal and regiform, it's obviously a non-magnetic material, right? So this should be our answer, but we'll check the other answers as well. Here, next one is given coins and aluminium. Aluminium is non-magnetic, we know that. Coins, you know, coins, some coins, there are some coins, those coins are magnetic materials. So this is incorrect. Iron rod and strings. Iron rod, it's definitely a magnetic material. So this is also wrong. Needles and file clips, both the things are magnetic. So this is also wrong. Right, so the correct answer is copper and regiform. So those are the things which are not attracted to a magnet. So my dear children, now we have discussed about several MCQ questions, multiple choice questions, right? So in the next chapter, we'll discuss some activities or we'll discuss some questions which we need to write the answers, means some kind of essay type questions in the next chapter.